This 101 Introduction to Electrical Generation covers Faraday's law of electromotive force, or EMF, the stator and rotor in a brush generator, the stator and rotor in a brushless generator, and why most generators are brushless. Faraday, one of the founding fathers of electrical generation in the 1800s, wrote the law named after him, stating, "An electromotive force will be induced into a conductor moving through a magnetic field. A magnet has two poles, north and south, at opposite ends. Between the two poles is a magnetic field. Faraday discovered when a conducting wire, such as copper, was moved or crossed at right angles within the magnetic field, an electromotive force, or EMF, was induced into the wire. In other words, an electric current. A brush-designed generator utilizes rotating conductors. Following Faraday's law, a magnet is used. In a brush generator design, the magnet is the stator or static part of the generator. The magnetic field flows between the north and south poles of the magnet, functioning as the stator in a brush generator. As a wire conductor rotates inside, the magnetic field and electromotive force is induced into the wire, with peak current being when the wire is at right angles to the magnetic field. The current in the wires flows to the commutator attached to each end of the wire. Brushes attached to the commutator pick up the current, and a voltage will flow to a connected load via the wire to the connected load. Brushes connected to the commutator pick up the electric current, and a connected voltmeter or ammeter will indicate current is flowing. Brushless generators are different from brush generators because the rotor is now the magnetic field and the wires where the EMF is induced are static. In a brushless arrangement, the rotor component is now the magnetic field, and the stator component where the electromotive force is induced is static. Connection to the power generated is through solid contacts as the EMF is induced into the stator component, which eliminates the need for brushes. Today, most generators are brushless for two key reasons: reduced maintenance due to the elimination of brushes, and by power being induced in the stator, it allows more voltage options from one generator. In summary, multiple voltage options of brushless generators over brush generator voltages have to be as the commutator dictates. Brushless stator coils can be reconnected for various voltages. The other major advantage is the elimination of brushes as a service item. Brush surfaces arc between commutator surfaces. Friction and arcing lead to carbon buildup and wear. Brushless generators have a longer period between maintenance cycles and reduced costs. In summary, generator manufacturers today choose brushless generators.